Okay, grade 12. Now, the question that we will be covering in this video is a true test to your skills and knowledge surrounding Euclidean geometry, but not only Euclidean geometry, more specifically, the rules surrounding your center and your diameters. Now, why is this so important? Well, because you cannot be propelled in the direction that will allow you to fully succeed in the with regard to Euclidean geometry if you do not have a solid foundation on the knowledge of your centers and your diameters, right? So that forms the foundations upon which you build success in your understanding of Euclidean geometry. Now that is where we start. That is the starting point, right? And so if you if you redo this question on your own, if you redo this question on your own, meaning that you do not copy and paste from the memo. Okay, so you need to you need to trust the fact that you understand everything. What you If you get it right, what I want you to do is I want you to reaffirm the fact that you might you might have started making a bit of progress. Okay, we have progress and you're most probably improving. And by the way, this question is not hard at all. Okay, it's not difficult, but you know, like I said, it's, well, at least to my standards, it's not difficult. But if you are able to go over this question on your own, that means you've truly made progress. Okay, so without further ado, let's get started. Now, look at this question that we have over here. We have 9.2 AOB and COB are diameters of the circle. ACDBE with center O. Chords ACCB, AE, and DE are drawn. Now, D is 50 degrees. Now, diameters. So, what we want to do is we want to highlight the diameters. We have AOB. Okay, and by the way, this is a little arrow. This is a little error. I know you can see over here they've stated the fact that it's COB. No, it's COB. It's not the diameter. They probably meant to say COE, not COB. So we have AOB, COE. So what I want to do is we're gonna first, and by the way, when they mention anything about diameters, we really think of angles in a semicircle. Now, what does that imply? What does that mean? Now, that means a diameter will always subtend a 90-degree angle. Now, what you want to do is you want to take your pencil on both ends of the diameter and you want to trace the lines all the way to the other end of the circumference of the circle. You know, do the exact same thing on the other side. Start tracing the lines on the other end of the diameter. Trace it, trace it, trace it, all the way to the other end of the circumference of the circle. And so what does that mean? That means the lines that we've traced ended right over here on C, meaning C, with this part of C and that part of C, so it's C1 and C2, meaning C1 and C2 will be equal to 90 degrees. Very simple, very, very easy and very simple. And this question, there aren't a lot of things that can detract from us visibly seeing, which angle will be, subtended by angle A or B, because yeah, there isn't really a lot going on over here. And so we know that C1 plus C2 is equal to 90 degrees. Now let's say COE is, which I'm pretty sure that's what they meant to say or to state, COE is a diameter. Do the exact same thing. Start tracing the lines that stem from the diameter. Trace it all the way to the other end of the circumference of the circle. It ends right over here at A3. Do the exact same thing on the other side. It ends over here, right next to A1. And so we know that these blue lines, we can see that the angles that are in between these blue lines would be A3, A2, and A1, meaning that A3, A2, and A1 equals to 90 degrees because of angles in a semicircle. And please don't forget to, substantiate your answer. Don't forget to validate it. Otherwise, you're not going to receive the marks. Okay, you're not going to receive the marks, okay? So I'm just going to go back and annotate this on my diagram, and don't forget to annotate it. So we know that A3 plus A2 plus A1 is 90 degrees, and we know that C1 plus C2 is 90 degrees as well. Now, what else do we think of when we think of diameters? What do we think of? We think of radii. And so when we continue on with the question, we can continue reading the information in the segment. It is stated that O is the center. Now, we associate certain rules and ideas and concepts and theorems when we see the term center, or just, yeah, the center, which is the midpoint of a circle. So we think of radii, we think of diameters, we think of line from center to midpoint of chord. We think of angle at center twice as much as angle at circumference. So now we want to identify the radii. A radius is a line that stems from the center and touches the circumference of the circle. So OA is a radius, OB is a radius, OC is a radius, OE is also a radius. What we want to do is we want to identify the theorem that is applicable to this question. Now we've identified all our radii. Now what we've whilst doing this, after following the process of us identifying the radii, what we also come to see is that there are isosceles triangles that are clearly visible, right? We've we've also we've also identified isosceles triangles, right? So what is an isosceles triangle? An isosceles triangle is a triangle in which two sides of the triangle that form a part of that triangle are equal to each other. So we know that, and so we know OAC is an isosceles triangle, AOE is an isosceles triangle. And what do we associate isosceles triangles with? We associate that with opposite angles equal sides. So now the angle that comes before each equal line is equal to the opposite angle that comes, before the other line. So for instance, C1 is equal to A3 plus A2. Okay. And you want to use different colors to annotate your diagram. So that means A1 will equal to E1. And okay, so OEB is not an isosceles triangle. That is just, that's just a line that it forms. It's literally subtended by arc BE. It doesn't really form a closed triangle. No. Okay, so now opposite A1 equals to E1 because of opposite angles equal sides. C1 equals to A3 plus A2 because of opposite angles equal sides. Now let's continue on. We're going to identify. We're going to see if angle at center twice as much as angle at circumference is applicable to this question. Now, what a lot of students do is they make this mistake of only trying to identify a little bow tie shape, okay, where that there's like one part of the bow tie that is a lot shorter than the other part of the bow tie. No, what you need to do is you need to approach this theorem with strategy. You need to approach it in a methodical way. Okay, you need to apply the method that I'll be showing you. So the very first thing that you want to do is you want to identify the center. Okay, so the center would be O1. We can clearly, well, the center is divided, it's partitioned into different parts. It's O1, O2, A3, and O4, and O3. So now we have O1, and you want to identify the arc that O1 is subtended by. And so how do we do that? You want to do the exact same thing, you want to use the exact same method that we practiced previously. Use the exact same method, okay? And so what you want to do is you want to first identify the line that stem from O1 and trace it all the way back to the circumference of the circle. It ends right over here at O1. So, and then you want to do the exact same thing on the other side. Trace the lines. It ends right over here by E1. And so you want to connect those two lines so that we can identify the arc that subtends that angle. And so we can see that the arc that subtends O1 would be AE. Okay, so that's worth noting. Right. And so let's do the exact same thing to all the other angles that are on the circumference of the circle. Do the exact same thing, or we want to apply the exact same method to D. So we're going to trace the lines all the way to the other end of the circumference of the circle. It ends right over here at both A and E. You're going to connect those two lines, and and by doing this, we can simultaneously see that AE is the arc that subtends D. Now this is pretty interesting because O1 is subtended by that very same arc too. That by that very same arc. And so what conclusion can we draw from this? Now the conclusion that we can draw from this is that angle at center twice as much as angle at circumference applies to both O1 and D. And so what does that mean? That means O1 will equal to 100 degrees because of angle at center twice as much as angle at circumference. See, that's very important. But that it doesn't just stop over there. Now, you might argue and say that O1 and D are very you can clearly, if you look very carefully, you can see that a structure, a sort of generic structure that you'd usually, if you go through your notes in grade 12, you would see it looks like an arc. And so then there's a space underneath that part of the arc, and you can argue and say that, okay, you have to identify a structure that looks like that, which is completely wrong, completely false. No, that is not the case. And so what you want to do is you just want to use that exact same concept of identifying the arcs that subtend angles. You need to adjust yourself to to these methods. Okay, you need to approach it with logic. Okay, you need to approach it with logic. Okay, and so let's do the exact same thing to C1, for instance, or O4. Let's do the exact same thing with O4. You want to do is you want to take your highlighter, trace the lines all the way back to the circumference of the circle, ends over here. Do the exact same thing on the other side, ends over here, which is that means it's subtended by arc. It's subtended by arc AC. We're going to do the exact same thing to any other angle that's on the circumference of the circle. Let's do the exact same thing to E. Trace the line all the way over onto the other side of the circumference of the circle. Do the exact same thing on the other side. Trace it all the way onto the or back to the other part of the circumference of the circle. It ends over here, so we know that E1 and O4 are subtended by the exact same arc. Okay, so we just want to take note of this. So we don't want to annotate this onto our diagram because it's going to cause a catastrophe. Like a yeah, it's just going to be a whole myth. And so what we want to do is I'm just going to take note of this O4 E1. That's it. So we don't forget. Okay, so we don't forget that. Okay, so now let's continue on. Okay, so we still want to, and by the way, we want to do this for each and every single angle that is on the circumference of the circle. Okay, so now we're going to do the exact same thing to O2, each and every single part of the center of the circle. So now if we trace the lines from O2 all the way to the other end, it ends over here. At E, do the exact same thing, it ends all the way over here. So we know that it's subtended by BE. Now let's pick any other angle that is on the circumference of the circle. I'm just going to pick C2, and you want to trace the lines from C2 all the way to the other end of the circumference of the circle. Do the exact same thing on the other side, trace it all the way to the other end of the circumference of the circle. It ends over here, right over here by BE. They're subtended by the exact same arc. And so the conclusion that we can draw from that is that angle at center twice as much as angle at circumference is applicable to both C2 and B1. So we want to add that to our list. So C2 and O2. So now let's continue on. Okay, let's continue on. Now the only angle that we have left to do this with is O4. Do the exact same thing. You want to practice. You want to use the exact same method. Okay, so trace the lines from O4 all the way to the other end of the circumference of the circle. It ends over here. Do the exact same thing on the other end. Trace it all the way to the other end of the circumference of the circle. It ends over there. So we can clearly see that it's subtended by arc AC. And so we want to pick another random angle on the circumference of the circle. There isn't a specific angle that you need to select. Just select any. You never know. You never know which angle this might be applicable to, or which angle will form a part of, or will contribute to us identifying or being able to use angle at center twice as much as angle at circumference. Now I'm just going to randomly select E1. Trace the lines all the way from the other side of the circumference of this, or trace the lines from E that stem from E1. It ends over here. Okay, trace the other line to the other end of the circumference of the circle that ends over here, meaning it's subtended by AC. So O4 and E1 are subtended by the exact same arc, and so angle at center twice as much as angle at circumference will be applicable to those two angles as well. Okay, so we just want to take note of this. So we said it was O2 and C2, O4 and E1, which we've written down. Okay. One other angle that we would like to apply this method to would be angle B. Trace the lines from B all the way to the other end of the circumference of the circle. It ends over here. Do the exact same thing on the outside. Trace it all the way to the other end of the circumference of the circle. It ends over here. So that means B subtends arc, or B is subtended by arc AC. O4 so happens to be subtended by that exact same arc. So that means angle at center twice as much as angle at circumference will be applicable to O4 and B. So I'm just gonna add that onto the list. Okay, so now, okay, so what we want to do now is we want to continue on. Let's continue on with the questions. 9.2.1, calculate with reasons the size of the following angles. Oh, and now that's very easy. We've already come to our answer. We've already calculated the value for O1, and it was 100 degrees because of angle at center twice as much as angle circumference. Okay. So that's very important to remember. It's very important to annotate. O1 equals to 180 degrees because of angle at center equals to twice as much as angle at circumference. Now let's continue on with the next question. 1. Calculate the value of E1. Okay, so E1, the very first thing that you need to do is you need to identify or try and see if it is somehow directly connected to any other angle, directly equal to any other angle. Yes, it is. It's equal to a1, but we don't know what the value of a1 is. The next thing that you want to do is you want to identify the triangle that it is a part of. Yes, it is. It is a part of triangle AOE, and AOE so happens to be an isosceles triangle. Now, if you have an isosceles triangle and you don't know what the other values of the other two angles that are a part of the triangle are equal to, that is not an issue at all, okay? What you want to do is you want to label both A1 and E1, just assign a random variable to them, and I'll show you exactly why. So what I'm going to do, but you have to let the marker know. So I'm going to make A1 equal to X. Okay, so let A1 equal to X. And so if A1 is equal to X, that means E1 will equal to X. Okay, but you have to let your marker know. Okay, the marker has to know. So obviously, if A1 equals to X, that means E1 will equal to X because of opposite angles equal sides. And so what we want to do is we want to calculate the value of, X, because if you calculate the value of X, we will be simultaneously calculating what E1 is, because we've assigned a random variable to E1, which so happens to be X, right? And so what we want to do is we want to formulate an equation. We're going to use sum of angles of a triangle. Very easy, guys. Why is that? Because we have two variables. We have A1 and E1, which we've assigned a variable to them, which was X. It's an unknown variable, and we want to find out what that unknown variable is. Okay, and so what we have to do is we have to use sum of angles of a triangle. So we're going to say 100. Now x plus x is 2x equals to 100 degrees. Reason is sum of angles of a triangle. We're going to take the 100 over onto the other side, leaving us with an answer of 18. And then 2 divided by 8 is 40. And so we know x is equal to 40, meaning E1 will equal to 40 degrees. But please make sure that you substantiate your answer, you validate it by giving the reasons, by stating the reasons. So A1 equals to, oh wait, sorry, 9.2.1b, O1 equals to 100 degrees. Yes, that's something we've already calculated. A1 equals to E1, angles opposite, equal sides. You don't have to say angles opposite, equal radii. You could do that is also a sufficient, that would be validated, that's also valid. But you can use opposite angles, equal sides. Okay, and then you're going to use sum of the angles of a triangle, and then your answer is going to be E1. And what you want to do is you want to annotate that onto your diagram. Okay, so 40 degrees, I'm just going to leave that as being equal to 40 degrees. Okay, then for next question, 9.2.2, prove that AE is parallel to CB. And so what you want to do is you first want to list out all of the different options that are available to us, right? So if we want to prove that two lines are parallel to each other, we would have to prove alternating angles, or we would have to prove co-interior angles. We would have to use, identify maybe two angles that are equal to each other that are in that alternating position, or we could use co-interior or corresponding. Okay, so now the most, I would say that, well, I don't create any sort of hierarchy, but it is always best to try and see if you can identify angles in that alternating position. Okay, so CB, just want to highlight this. So CB, okay, that's 90 degrees. So we have CB and AE. So what I want to do is I want to try and see if there's a diagonal line between those two, like a diagonal line between those two lines, to see if we can identify any angles that are in that, alternating position. Now, so we could prove that C2 equals to E1, or we could prove that B equals to A1. But the only problem with B isn't really, directly connected to another angle, so it might be a lot difficult, might be a lot more complex and, difficult. So we want to start off with the obvious angles, or yeah, the angles that are in an obvious, it's like in an obvious position. So let's see if C2, we can prove that C2 equals to E1. Now, first and foremost, we have to identify an angle that C2 equals to directly. Now, sorry, I think I erased my annotations, but you can clearly see that A1 equals to C2 because of angles in the same segment. So we actually have a cyclic quad. Okay, and our cyclic quad would be, and by the way, this is actually very important to go back and identify because they actually did not give us that information in the segment. So A1 equals to C2 and E1 equals to B because of angles in the same segment. Okay, because angle, we can clearly see that there's a bow tie shape. So and we have A, E, B, C is a cyclic coil. So E1 will equal to B as well. Okay, and so we know what you want to do is if you want to prove that C2 equals to E1, you want to list out all the angles that both E1 and C2 are equal to. Let's start off with E1. Okay, so we can clearly see we've already stated that E1 equals to A1 because of angles opposite equal sides, right? So I'm just gonna list that. I'm just gonna place that onto my list. And now, what other angle does, and then so once you've identified what angle that E1 is equal to, do the exact same thing to C2. What angle is equal to C2? Directly equal to C2? A1 as well. Wow, and that was very easy. A1. And so they both have an angle that they have an angle that they have in common, which is A1. They're both equal to A1. And so what does that mean? That means E1 will equal to C2 because they're both equal to A1. Okay, but you have to structure your answer in a certain way. It has to be structured. It has to be very organized and structured, right? So you want to validate your answers with statements. And so what you want to say is that A1 equals to E1, which we already stated because of angles opposite equal sides. But A1 also equals to C2, which I've already identified because of angles in the same segment. Therefore, E1 equals to C2 because they're both equal to A1. And so for that reason, those two lines are parallel to each other. But you need to, you need to conclude, you need to end that off and substantiate why it is that they're parallel to each other. And that's because alternating angles equal, meaning that we've identified angles in that alternating position, and we've proved that they're equal to each other. Okay, so we know that they're equal to each other in that alternating position. That means alternating angles equal.